Hi everyone, welcome back to the channel. I'm the GCSE science teacher, and in today's video we're going to be talking about a brand new topic for paper 2 GCSE chemistry, and this is all about organic chemistry. So we're going to focus today on crude oil, alkanes, and also a method of separating crude oil called fractional distillation. So if that sounds good to you and you do enjoy the video, please do give it a big thumbs up, share this video with someone else so they don't miss a upload from me and they don't miss out on any key revision. But also, if you haven't already, please do subscribe. It would be amazing to have you as part of our community. And thank you so much if you have recently subscribed. It's lovely to have you here. So let's get started. Crude oil then, it's a finite resource. It's a really valuable resource as well because there's not a huge amount of it. And because it's finite, that means we cannot get any more of it within our lifetime. But where does finite resources such as crude oil come from? Well, they actually come from the earth itself, and it's made up of dead organisms that lived and died millions and millions of years ago. So honestly, the main type of organism that makes up crude oil is actually plankton. And this has been a very small creature that was living millions of years ago, died millions of years ago, and was buried under high pressure and heat underneath a layer of mud. And over time, that has crushed and broken down into crude oil. Crude oil is a mixture of hydrocarbons, and a hydrocarbon is just a molecule that contains only hydrogen and only carbon. And we find this at the Earth's crust. If we were to dig underground, even in the seabed itself, we can actually extract crude oil from the Earth's crust. And this can be obviously very useful because crude oil can be used for many things like fuel, but also because we're digging into the earth itself, it can actually cause a lot of destruction with habitats. In fact, there was a big oil disaster several years ago where a lot of the oil actually spilt onto the surface of the sea because oil is less dense than water, so it floated on the surface of the sea, and that actually caused a lot of destruction to organisms there. And I'll leave some information if you're interested in the description box below for further reading if you would like to learn more. So essentially, crude oil is a useful resource, but it can also cause lots of habitat destruction. So it's kind of weighing up the pros and cons there. Like I said, crude oil can be used for things like petrol and diesel if we are to separate crude oil into those fractions, and we'll talk about that today. But it can also be used in other industries. It can be used for detergents and solvents, and also the petrochemical industry as well. So it's very multifaceted in its ability to be used. So in the exam, you will be expected to know about two families of hydrocarbons. You've got the alkanes, which we're going to talk about today, and also alkenes as well. Because they're both hydrocarbon families, they both only are made up of hydrogen and carbon. However, there are a few differences that you need to know about them. So alkanes, like I say, they are a family of hydrocarbons. We actually call this a homologous series because we actually know that they have the same general formula. This means we can actually predict the number of carbons or hydrogens in that formula if we are given part of the information. So the general formula that you need to know for the exam is CnH2n+2, and N just is the number of carbons, for example. So if we know there's one carbon, so N equals 1, we can do the following with the hydrogens. We could do 2 times 1 plus 2, which gives us an answer of 4, and that will make the molecule methane, CH4, which you've probably heard of before actually in the curriculum, because methane is a greenhouse gas that's released from cattle farming and also landfill production as well. You can see the displayed formula and the structural formula for methane there. You can see all of the bonds. Carbon, remember, can only make 4 covalent bonds. It's covalent because they are both non-metals, and that's really important. Remember, a covalent bond is a shared pair of electrons. If you'd like to learn more about bonding, I'll link a video for you as well. So we know that they are going to have the same general formula, but also because they're in a homologous series, they have similar chemical and physical properties as well. They also have the same functional group, which is the carbon-carbon single bond. And this is what we call a functional group. We also can say that they are saturated hydrocarbons because that bond is singular. If it was a double carbon bond, we'd say it was an unsaturated hydrocarbon in the case of alkenes, which we'll talk about in the future. The 4 hydrocarbon alkanes you need to know about are methane, which is the first one, ethane, propane, and butane. Those are the key ones that you need to know for GCSE. But of course, with anything, there is obviously more of these, especially as you go into A-level chemistry, you'll learn a lot more about those different long chain hydrocarbon alkanes as well. But just for fun, could you predict the formula of decane? If I told you decane has 10 carbons, how many hydrogens would it have? Use the general formula and predict its formula overall. The solution will be in the description box as well. So fractional distillation is a method we can use to get the different fractions, the different alkanes, and actually make use of them, because in its raw form, crude oil is not actually very useful. We actually have to do something with it to get anything from it as well. So if we look at the word fractional distillation, we can actually break it down into its two words. So fractional or fraction just means, like in maths, you're taking something from a whole. And that's what we're doing here. We're actually taking small parts of the crude oil and using it for different uses. Distillation just is a separation technique that you may have come across before, such as simple distillation. If we had salt water solution, we could heat up that liquid, that solution, and that would actually cause the liquid to vaporize into a gas. We can cool this down, it will condense back into a liquid, and we can get the pure water from the salt water solution. So we can separate the salt and water from that situation that we talked about there. The same thing is actually happening in fractional distillation. In this case, instead of water, we're using crude oil. Remember, it's a mixture of hydrocarbons. And because of that, we can actually heat it up. It's a liquid at the moment. We can heat it up to 350 degrees Celsius, and it will go into a fractionating column, which is the big silver cylinder you see there. And as it's heated up, it will actually vaporize. So those hydrocarbons will vaporize and form a gas. Now, this is really important because those gases will actually cool down as they reach the top of the fractionating column, and it cools to around 25 degrees. Now, some of those are very short chain hydrocarbons, and they will just be fractioned off as liquefied petroleum gas and stay as a gas. However, some of the longer chain ones will have much higher boiling points, and they will then be fractioned off depending on their boiling point. So the smaller the chain, the lower the boiling point, and this is all to do with something called an intermolecular force. So because hydrogen and carbon, they are connected through a covalent bond, if we have a mixture of hydrocarbons, it's not the covalent bonds that are breaking in this case. This is a misconception. It's actually the intermolecular forces between the molecules. Remember, crude oil is a mixture, so it has all those chains that are together. Between those chains, what's holding them together is something called an intermolecular force. And as those break, they actually can be separated. So that's what's occurring here. It's not the covalent bond. So what you end up with is a range of different fractions. So liquefied petroleum gas would be tapped off first because it has a lower boiling point. Then petrol would be, then kerosene, then diesel, then heavy fuel oil, and then bitumen. Now you need to know the order of these. And one of the ways I like to do this is using a mnemonic. And there's loads of different ones, but the one I've come up with is lively puppies, no dogs howl and bark. And this has helped me kind of remember the order, but also you do need to be aware of the uses of these as well. So we'll run through them together. So liquefied petroleum gas is used in general homes for cooking, for heating. Petrol, as you probably know, is used for cars and buses and general transport. Kerosene is actually used for aircrafts, and diesel is again used for general travel, but also can be used for trains as well. Heavy fuel oil can be used for ships, and bitumen is often used for roads and roofs as well. So those are the key ideas that you need to know for fractional distillation. I will leave the mnemonic in the description box as well. If you'd like to copy it into your notes, feel free to do that. And if you come up with your own mnemonic, do let me know in the comment section. I'd love to hear from you as well. And that's it from me today. I've been the GCSE science teacher, and you have been curious. If you did enjoy the video, please do give it a big thumbs up. Do share it with someone, and also do subscribe. I would love to hit 100. We've already got past the halfway mark. So if we could get 100 subscribers here on YouTube, that'd be amazing. If you would like to learn more biology, chemistry, or physics GCSE content, check out the videos and playlists on the side there. You can also find more of my content for GCSE sciences on my Instagram and TikTok. All of it is at the GCSE science teacher. And I hope you did enjoy today. If you did, let me know in the comments, give it a thumbs up, and I'll catch you in the next one. Bye.